So, continuing, if we understand how the switch works, where the learning, uh, flooding slash broadcasting, filtering, forwarding processes, then it makes it much easier to understand how some of these attacks work and probably how we can mitigate them. Number one, we have the MAC address table flooding attack. How do I remove this, Mara? Right. Right. We have the MAC address table flooding attack where all MAC, okay, starting with that, all MAC tables have a fixed size. A switch can run out of resources to store the MAC addresses. MAC address flooding attacks take advantage of this by bombarding with fake source MAC addresses until the switch MAC address table is full. When this occurs, switch treats the frame as an unknown unicast and begins to flood all incoming traffic out all ports on the same VLAN without referencing the MAC table, allowing threats to capture all traffic. Right. So this one is very simple. MAC address flooding attack. The ultimate goal basically is to overwhelm the MAC address table. So MAC address table, it is a fixed size, very limited, probably. Then we have, take note of this, Markov is my, right. Uh, a little bit of research on that mark of, it's probably mark flooding. Right, so like I was saying, the goal is to overwhelm the MAC address table since it has a fixed size. So the number of MAC addresses it can learn, it is fixed. So an attacker basically sends my frames from unknown sources, unique every time, using this. That is a tool, that Markov tool is a tool. And after you send my unique frames to the MAC address table, to the switch. Initially, the switch learns all those unique uh, addresses up to a point table inenge yazara. Table ikazara, it means everything else chiri kusendwa, the switch can no longer learn. If the switch can no longer learn, it means it is always flooding. If the switch is always flooding and an attacker is on the network, it means basically an attacker can eavesdrop, sniff all the traffic iri munetwork. So tikadai so for example, attacker wedu ari network akasenda ma unique frames ake up until uyedi yazara, it means even if this one tries to send legitimate traffic, this switch will flood. But no flood even to the attack. That is what flooding is, broadcasting. Information ikasvika pana attacker using some tools, then attacker can sniff. I think one of them ndo Wireshark. I think we introduced you to Wireshark. Saka attacker kana ane Wireshark pano broadcast kwa traffic from other legitimate users. That's how they get to sniff, let's say eavesdrop. That's how they get to eavesdrop on that traffic. Mitigation. How do we mitigate against that? What makes tools like Markov so dangerous is an attacker can create an overflow very quickly. So for instance, that switch, it has 132,000 MAC addresses, and that tool can send up to 8,000 bogus frames per second. What's 8,000? 132,000 divided by 8,000. Let me see. How many seconds it needs to flat 132,000 divided by 8,000. 16 seconds. So within 16 seconds, 17 actually, within 17 seconds, MAC address table inenge yatozara kudara. It means it doesn't take much for attacker to start receiving my packets from devices, my frames from devices within the network. Another reason why these attacks are dangerous is they not only affect the local switch, they can also affect other connected layer 2 switches. Yes. Why? Because once we begin flooding, so if I have an attacker pana iri kana razara iri, if it is connected to another switch, it means iri ringoflooda still. Rikaflooda, then information painodzoka, it is still getting flooded. Iri ndorine problem. So information yese inenge ringofloodwa out all my egress ports. As long as my frames are kufloodwa, then attacker always gets access to traffic from legitimate users. To mitigate, we have port security. The administrator has to implement port security, which will only allow a specific number of source MAC addresses to be lent on a given port. Right. So I think in the next module, that's where we will discuss some of these configurations. So instead of a given port to learn probably part of this 132,000, you realize with port, we can configure it so that it learns only two source MAC addresses. Rikangoita learn those two, then it doesn't take anything more. So meaning even attacker akatry kusenda these bogus frames 8,000 per second akwanisi, because on that specific port rina attacker anenge ari limited to at least two in the example and up, two maximum addresses. So basically that's how we implement port security to mitigate against MAC address table attacks. Right, then we go to LAN attacks, VLAN hopping. Ooh. Right, with LAN attacks, we have attacks which primarily targets my switch, my access points. In this case, it's not only my switch. We have my attacks which target my access points as well. Going as far as my routers, as much as we are focusing on layer 2 attacks, some of these LAN attacks anosvika to my routers edu. Obviously, my endpoints which are connected to the networks. Some of the types that we're going to discuss. So we have VLAN hopping, TCP. So LAN attacks, we have VLAN attacks, ARP attacks, STP, address spoofing, DHCP attacks. So let's discuss my attacks ADY. Yo, VLAN hopping. Excuse me. All right. A VLAN hopping attack enables traffic from one VLAN to be seen by another without the aid of the router. Right. If you understand my VLANs edu, we said if I have a device in VLAN 10 and a device in VLAN 20, without a router, traffic in VLAN 10 cannot go to VLAN 20. I think that's the knowledge we got from my VLANs edu. See. Yeah, power. Just a minute. Okay, so VLAN hopping attacks enables traffic from one VLAN to be seen by another VLAN. As I was saying, traffic from VLAN 10 without a router, like 1 second of VLAN 20, could traffic isvike, there is need to have inter-VLAN routing. There's a router up, then we are able to route traffic shift from 10 to 20. But VLAN hopping, however, even a router recipe, traffic can go from this VLAN to this VLAN. That's how those attacks happen. Let's look at the process. In a basic VLAN hopping attack, the threat actor configures a host to act as a switch to take advantage of the automatic trunking port feature enabled by most switch ports. Actor configures the host to spoof the DTP signaling to trunk with the connecting switch. If successful, the switch establishes a trunk link with the host. Now the threat actor can access all the VLANs on the switch. Right. So here, how does it happen that in a threat actor gets access to traffic from different VLANs? When we discussed DTP, I think there was an issue to do with security risks which comes with the dynamic trunking protocol. If switch rako ukarisiya riri pa DTP desirable, for example, it means if an actor, for example, if DTP is enabled, it means this device can connect to this port, then configure itself as a trunk, meaning link iri rinenge ratrunking. Link iri rikangoita trunk, it means multiple VLANs can go through this link. If multiple VLANs can go through this link, then it means attacker can get access to multiple VLANs. That basically defines the absolute VLAN hopping. It basically makes use of vulnerability which comes with the dynamic trunking protocol, allowing an attacker to get access to multiple VLANs via the trunk. The other one, we have VLAN double tagging, right? It's a form of VLAN hopping inonzi DTP spoofing. Right. So this one, inonzi DTP spoofing. So it's a form of this attack inonzi VLAN hopping. So to DTP spoofing, we also have double tagging. Those are the two forms of our VLAN attacks that we have. With this one, it's a bit complex. It's a, it's a bit complex. Step one, threat actor sends a double tagged frame to the switch. Step two, frame arrives on first switch. Step three, frame arrives on second switch. So with this one, we know tagging. Let me try to convert this one. Switch. Right. That VLAN hopping, it means an attacker is getting access to another VLAN without my services router, without my services inter-VLAN routing. Yatatanga kudescribe yashandisa TTP spoofing, where an attacker connects to a port configure a DTP, then or create a trunk link on that port, which allows multiple VLANs to traverse through that link. The other one now, it's double tagging. So let's say attacker I don't want access to VLAN 20. Attacker anogadzira a frame rake rinenge rine two matag. So rinenge rine tag on the outside, rinenge rine tag relative VLAN, then on the inside oisa VLAN 20 tag reVLAN yaarida kuataka. Saka panosvika panoprocesswa this frame paswitch iri, switch iri rinoprocessa the native tag. Ayaya, que pasa? Native then v20. Right, no frame ready. So panoprocesswa frame ready at this switch, no switch number 1, this is switch number 2. Chinoprocesswa itag rekunze native tag rikaprocesswa ndo rinoreva kuti we have untagged traffic. As much as traffic yabva pana attacker ndiye anogadzira frame rake as if it is coming from an untagged VLAN. Therefore, rikatonga rubva from an untagged VLAN, rinoenda kunoshandisa the native VLAN. That's how it gets passed through here. Another vulnerability which allows kuti ipfuure up ndo yekuisa native VLAN iri VLAN 1. Native VLAN ikaiswa iri VLAN 1, it basically means everything chiri untagged chinotokwanisa kupfuura up. Kana makanyatsoverenga, you probably realize kuti makanzi native VLAN inofanira kuchinjwa. I think they usually use 99 or 100. The reason why ichifanira kuchinjwa, because ikachinjwa, in this case ikachinjwa kuenda ku99, attacker panapa even if akasenda packet rake riri native harikwanisa kuzopinda apa, because native VLAN yabviswa kudefault. Because attacker port iri kana risina kuconfigure any VLAN, it means rinenge riri by default in VLAN 1, therefore allowing native VLAN 1 as well panapa kuti ripfuure. Get that? That's part of security yekuchinja native VLAN kubva ku1. So let's say haida kuchinjwa, it means attacker akasenda uye rake rine native, parinosvika panapa rinokwanisa kupfuura because rine tag native. Then parinosvika panapa tag native inenge isisipo ichi, panenge pasara chi tag VLAN 20. Parinoprocesswa panapa switch number 2 rinoona VLAN 20, allowing it kuti rikwanise kuenda kuVLAN 20. That's basically what double tagging is. That's how an attacker can get access to another VLAN, masking a frame with two tags. One outer tag native and the other one target VLAN, basically. That's VLAN tagging attacks. So mitigation, number 1, native VLAN gave a default. That's part of mitigation here. Yeah, double tagging attacks. The other ones has disable trunking on all access ports. Right? Disabling trunking on all access ports is doing mitigation is spoofing ish. Because maports ako maisa ko trunking, it means end device ikauya attacker anokwanisa connected to that trunk. EO actor as a trunk auto create a trunk link, therefore mamount VLANs out of fora. Disabling auto trunking on trunk links so that the trunks must be manually enabled. This is basically disabling DTP. Be sure that the native VLAN is only used for trunk links. That's another way of mitigating against our VLAN hopping attacks. What else do we have? DHCP messages. Excuse me. DHCP servers dynamically provide IP configuration, IP addresses, masks, default gateways, server addresses. A review of the sequence of the DHCP messages exchange is shown. So with DHCP attacks, we have to understand how DHCP messages are exchanged. So this is our DORA, discovery, discover, offer, request, and acknowledge. Like we said, when we do DHCP, it's very important to understand the type of messages that we have. Broadcast, unicast, broadcast, unicast. That's very important. So this is how basically DHCP messages are exchanged. Now, looking at the attacks, we have two types of attacks. We have the DHCP starvation and we have the spoofing attacks. Both, both mitigated by implementing DHCP snooping. Starvation attack. The goal is to create a denial of service for connecting clients. It requires a tool called the Gobbler, which is the ability to look at the entire scope of listable IP addresses and try to list them all, creating discovery messages with bogus MAC addresses. So with the starvation attack, an attacker basically floods the DHCP server with these bogus DHCP discovery messages. So my discovery messages ndo ma-broadcast anescopectanga trying to get access to my servers so that you can get an offer from those servers. So if an attacker sends a lot of those discovery messages, it means server will respond with offers. Kuma bogus discovery messages iwa. Ma offers iwa akauya anosvika pakupera. My offers why because DHCP doesn't have an infinite number of addresses. A server doesn't have an infinite number of addresses that it can provide. So akapera, it means now when a legitimate user is trying to get one of those addresses, they can send a discover message. The server is no longer able to respond to legitimate users on the network. So that is basically a DHCP starvation attack. Attacker broadcasts bogus discovery messages, denying service to legitimate users. The other one, spoofing attack, occurs when a rogue server is connected to the network and provides false IP configuration parameters, which can provide a variety of misleading information, including a wrong default gateway, wrong DNS server, wrong IP address. So this one, what it usually does, let me see, get to get about process here. DORA. So with this one, there is a bogus server. Server and DORA bogus, but the other one is starvation. Attack anenge at this end. Ndianenge ari kusenda up. So this end ndo kune starvation. Then the other is spoofing. Attack anenge ari kuserver side uku. Anoacta as a server So as soon as a legitimate client sends this a discover message, bogus server responds quickly before any other server responds. Because this is a broadcast, it means everyone can get that message. Bogus server no responder. Ne offer. Rover offer my parameters are wrong. Rover offer default gateway wrong. Default gateway wrong. Kune legitimate user but not ku bogus server. So usually default gateway rinopiwa ipapo allows the server itself or another attacker to play as a middleman to all the traffic. Chero kuti client iri panenge rauda kusenda network to outside the network rinenge rakushandisa chi default gateway yaattack. Attacker uzoendesa hake kwaada kuendesa, but traffic yese yapfuura pana attacker because maparameters apiwa a legitimate client they are false. So basically that's how a spoofing attack works. Bogus server, its goal is to try to respond quickly to the discover message, then offers wrong addresses. Consequentially, attacker gets to eavesdrop on legitimate traffic. Mitigation, but a mitigation. Okay, but mitigation, I take a spoofing, snooping. So mitigation, we have what we call DHCP snooping. So DHCP snooping basically deals with not trusted and untrusted ports. Not trusted ports in a case like this. Right. My trusted ports are. So I am not trusted. He reported as trusted. Can I look endpoint? Untrusted. So DHCP snooping basically it classifies my ports are network yedu, my one is my trusted, my one is my untrusted. So my ports are with between my devices either. Do I change my trusted? And then my end devices and I change my trusted. Why? If an offer comes from an untrusted port, it automatically gets blocked. Because offer alifana kuya from this port. It runs untrusted. Now, the connect a server app. DHCP snooping allows me to then configure manually pan app. Kuti port iri trusted because it's in a server, legitimate server yatiri. Then offer ikabva kunoko inenge yarobva from the trusted port, it won't get blocked. That is basically what DHCP snooping is all about. It's all about my trusted, nema untrusted ports. Starvation. So I think I've mentioned this. They're spoofing up server side. Then per starvation, there is a way to limit the number of discovery messages that send. So Panapa we can configure a DHCP snooping, which basically limits because the starvation attack deals with overwhelming server number of discovery messages akawanda. So if we can limit those messages at a given port, we can reduce masturbation attacks. That is basically what DHCP snooping on that end, the masturbation attacks. 30. How many slides do you have? 31, 32. 10 minutes. Right, then to end up ARP attacks. Again, if you understand what ARP is, how it works, it becomes easy to understand how the attacks are done and How do we then mitigate against them? So from what we know, ARP is basically used in mapping IP addresses, NEMA MAC addresses. So if we have a MAC address that we want to know is, if we have an IP address that we want to know is MAC address, there is a broadcast request that is sent. Broadcast request, I have this IP address, I need a MAC. Then the device with that IP address responds. That is the process, the ARP. However, an attack can corrupt my cache. Starting with the request, let's start with the request. Request yo can go to broadcast. An attack can send, for example, my broadcast akawanda ARP request ne fake IP address. Or send wakawanda, switch your processor kusvika pane the denial of service, because switch restack kuda processor my request a fake. That's one of my attacks ARP. The other one is not dealing the cache. Let's see. A client can send unsolicited reply. Other host on the subnet store the MAC address IP contained in this in their ARP tables. Okay, let's go through them one by one. Tangatara is probably Kumberi. So this one, that's an attack where a user legitimately requests for an ARP request. However, a response in way didn't get bogus. Attacker anotoziva kuti I have an ARP request, then anova respond quickly kuti ndini muridzi IP address. Then in the tables is updated. MAC address MAC address yeattacker inova update kwane legitimate IP address. Meaning every time pakuda kusendwa information to this legitimate IP address inenge yakuenda kuna attack. That's one way of how ARP is used by an attacker. Then an attacker can send an ARP message containing a spoofed message to the switch. In the typical attack, the actor sends unsolicited replies, effectively setting up a man in the middle. Okay, it's still the same one. So ERAP and E is still the same attack. There are many tools available. Creating ARP man in the middle attacks. IPv6 uses the discovery protocol for resolution. It includes strategies to mitigate neighbor advertisement spoofing, similar to the way IPv6 prevents spoofed ARP reply. Okay, in this one, they didn't mention which an ARP attack which results in denial of service. So this one is more to do with manipulation of the ARP cache, where attacker responded to a legitimate request of his own MAC address, which is bogus. Then every time legitimate users want to get access to that IP address, they'll be communicating via the attacker, basically. The other one, which was mentioned, is more to do with the denial of service. My request, a broadcaster, I don't send what bogus. I wonder. Then switch gets overwhelmed. That's how we have denial of service, basically. Mitigation, ARP spoofing. We have ARP spoofing and poisoning. We have dynamic ARP inspection. Then we go to address spoofing attacks. ARP spoofing. Address spoofing attacks, these ones are more Patambotaura ma-attack switch, LAN attack switch affect the router. These ones go there because they deal with my IP addresses. So a threat actor hijacks a valid IP address of another device on the subnet, uses a random IP address. A threat actor hijacks a valid IP address of another device on the subnet or uses a random IP address. Difficult to mitigate, especially when it is used inside a subnet. MAC address spoofing occurs when the threat actor alters the MAC address of their host to match another known MAC address of the target host. What else? When the target host sends traffic, switch corrects the error, realigning the MAC address to the original port. To stop switch from returning to port assignment, threat actor can create a program or a script that will constantly send frames to the switch so that the switch maintains the incorrect spoofed information. No security mechanism at layer 2 to verify the source of the MAC address. Mitigation, we have IP source guard. Address spoofing attacks, what do we have here? So here we have an attacker forging source address of packets or frames, acting as if it's an address of a legitimate user. That is basically address spoofing. The other one, same difference. Imwe inoshanda ne-IP, imwe inoshanda ne-MAC. Then mitigation, port security is one way of mitigating against my address spoofs. We also have DHCP snooping, which can help. Then obviously IP source guard. Yeah, it's open up. How many minutes? 1 minute. All right. Let's start one. I think one slide. Hang on for 5 minutes of one last session. Where are we in Africa? I think 2 or 3 slides. Let me stop this. One more session. Good.